Hello and welcome to Module 2, and we're going to talk about data structures in data science languages. So jumping straight in, what are we doing in Module 2? So what we'll go over today is talk a bit about the Module 2 at a high level, talk about the reading, then we'll dig into Python, some things around data types, probably also talk about data frames dictionaries, and then we'll talk about data frames in R, and then we'll talk about deliverable 2, and then not on the slide, but if we have time, I'll talk about Visual Studio Code, PyCharm, and Visual Studio Community Edition. These are alternative editors and IDEs, integrated development environments, that sometimes are useful whenever you're writing code. So we'll go through those, and I need to get my head somewhere else. So there we go. So jumping straight in, and thanks to Corey for joining. Appreciate that. So Module 2, what is it about? And it's about data structures, and there's a host of them, but we'll focus most of our attention on things like classes and data frames and dictionaries, and probably some vectors in there as well. And then for deliverable 2, we'll talk about that as well. We're going to use the Titanic data set. You're going to read some data, parse some columns that are interesting to you, do some filtering, and then produce some results. Reading. Pretty good material. Take a look at Chapter 3 in the Python for Data Analysis course, and then our step-by-step chapters 3 and 11. I believe Chapter 11 is around dates, and 3 is more around the data frames, I believe. So basic concepts is one of the things we'll start off with, and we'll talk a little bit about mapping and lambda functions, which is a way of doing what you might do in traditional programming languages with iteration, but it's a way of doing it in potentially a higher performance, and also something that yields itself later on to a distributed sort of processing, so comes in handy if you do something like Spark later on. Data frames and dictionaries, those are really important because you need to know you work with data, and data is most of the times tabular in nature. Data frames are perfect for that. Dictionaries are essentially associative arrays where you can look up a value based upon some key. And then pandas data frames, which frankly greatly influenced, if not was blatantly stolen from, for Python's pandas data frame. Some basic concepts around programming in general. Python's an interpreted language. There's not a compiler. There are versions that you can do that do compilation, but the native Python interpreter it evaluates it as it sees instructions. And that means you will have runtime errors. It's not if, it's you will, because we generally make a mistake. We sometimes mistype things and so on. So expect that you'll have to be doing some diagnostic and debugging. That's part of the things. And you want to keep that in mind as you're writing your program, so that you don't write something that's one big huge thing that you can't test in isolation. That's where things like Jupyter come in really handy, because you can do a cell at a time and break it down into a snippet of code. Pretty much everything in in Python is an object. There's several built-in data types that are handy, and you can always extend them with some additional libraries built upon these primitives. Text, strings, that sort of thing. Numbers, integers, floats, complex numbers, sequence types, that's where lists, tuples, and ranges come to play. Mapping types, it's a dictionary, associative array, way of associating a value with a key and being able to retrieve it when you need it. Set types, that's like a mathematical set. You use those to do the typical sort of set operations like intersection, union, and so on. Boolean, pretty essential to be able to determine if something's true or false. Binary types becomes important when you're dealing with things that are non-textual in nature, which is kind of the definition of binary, right? But that's things like images, audio files, things that would be considered probably not structured data. And then the type function tells you the type of a particular expression that you're interested in, so a variable, an expression, or whatever. And obviously, as I mentioned, pandas data frame. Pandas and NumPy are probably the two that you're going to use the most period. And they're libraries that you load in, and you get to where you just assume they're almost there, but they are extensions. Here's an example notebook. We'll go through this in a bit more iterative fashion, but basically showing some of the basic data types and so on. Drilling into some of these things, it's showing you strings, sequences, numbers, lists, and so on. A key thing, that the first line there is kind of redundant, right? So saying some string is equal to string of a string is really kind of redundant, because just putting something equals to a string is the same thing. But it is nice to know that string function will convert pretty much anything to a string, or try to anyway. And that's a way of doing type coercion or conversion, so it's important. The type function there, as I mentioned earlier, tells you the type of something so that you can determine what it is. And so again, we'll go through these in more detail in a moment. And in fact, we'll go ahead and do that right now. So jump over and do a bit more of a kind of interactive experience. So created a data type sort of exploration notebook in Jupyter. The basic idea here is to kind of let you see it in action, right? So as I mentioned, this right here, Alan, is a string, right? So if we add another cell and type in type and then Alan, guess what? It's a string, right? So really redundant to do this casting here or conversion. But whenever you're dealing with numbers, sometimes you need to do that to make sure that you get the right type of number, because you might have something that is there's ambiguity of what type it is. Not normally, but if you wanted 1, 2, 3 to actually be 1, 2, 3 as a floating point, so something that is not an integer, you'd either have to put 0 on there, so .0, or you would need to say that this is a float, right? So those are things that you can do, and that's exactly what this line that's highlighted is doing, is converting the integer of 1, 2, 3 to a floating point of 1, 2, 3, 0 right down here. And there are a lot of data types and a lot of data structures in both Python and R. Don't want to drain all of these, but I do want to make sure that we see some of them. Range is going to be pretty important for iteration. So if you want to do something similar to a for I equals 1 to 10 sort of thing, you typically do that over a range. That's the general pattern that you'll see. You can iterate across anything with a for loop, but that's where ranges come to play, and it's, as the name sort of implies, it runs from, in this case, from 0 to 5. Right, so it is literally the range in the mathematical sense. List is a collection of items, but there is some really handy and interesting things you can do with lists. One of the things that's not on here is, I don't believe, playing around with, I believe, and this is where it always goes badly at the point I try something that's unplanned, but if I do that, I believe it'll reverse the list. So yes, it does. So if you do colon and then negative, it basically will switch the order of things. This sort of pattern also applies on strings, which we talked about a little bit in the coding exercises of if you were trying to get a job with Python, things you might need to know how to do. It's kind of a little bit of a trick, but it may come in handy, especially if you literally want to just change the order of something. Maybe you sort it ascending and, oh, I really meant that to be descending, so you could easily switch them. A tuple is an interesting sort of construct. It's essentially a container, an immutable container, meaning you can't change it, of things. In this case, it's a tuple of 3 things, and those are they really can't be changed. It's kind of like a structure, but a little maybe lighter weight than you would think of a struct in like some of the other programming languages. Where it's really interesting, it can do things like coerce a string into a tuple of characters, and so on. The thing that's really interesting with a tuple is if you have a function that returns a tuple. That means that if you define a function and you want to get more than one thing out of it, you can return a tuple and then assign multiple variables on the way out of that, so you can essentially deconstruct the tuple into like 2 or 3 different variables. A nice and interesting way of getting around like the input and output parameters that we sometimes have to deal with. So it's pretty powerful. Lots of tricks in the bag. It's just a matter of kind of learning them and being prepared to use them as you encounter various situations. And also Stack Overflow is probably going to be your best friend for a while. Be prepared to Google it. Do If you use something that is very close to what it is, make sure you give it credit, right? So don't take credit for somebody else's work. That being said, you may want to use it as a way to figure out how something works. Once you figure out how it works, make it your own, and then there's no worries. A dictionary is kind of interesting because it's unlike some data types where in some programming languages, all of the indexes in your dictionary would have to be the same data type. A data type inside of a Python dictionary can be variant, right? So this is an example where I'm using a string as the key in this one and an integer for this one. So pretty interesting and kind of different. We talked about set types. There's also a frozen set type, which is something that essentially becomes immutable. You can't add, change, or clear it. So it's a way of kind of like freezing it or snapshotting it, and that's hence the name frozen. And so pretty interesting stuff. They have the normal operators you'd expect, such as intersection, union, and so on. Boolean, what you would expect is true or false, but also if you initiate it with anything other than 0, it is true. So if you pass in an integer other than 0 as into the equivalent of a constructor, it's going to be true. 0 is false, and that kind of is there's a history there, right? That's how it was in some of the early programming languages, so you would check to see, is it, basically non-zero is what you're checking. Binary types, as I mentioned, it's pretty much things that are either an array of bytes. You sometimes see that, but most of the time you're seeing things that are being loaded from a file, such as an image or perhaps audio or video or whatever. But it's something that is non-textual in nature and needs to be handled as an explicit array of bytes that you want to interact with. And then this is where you're doing basically you can change the type of a variable by simply assigning it a different value. That's because of the interpretive nature of Python. That may not seem like a really big deal, but in strongly typed languages, you couldn't do it, right? So you would have to say what X is, and you would assign it a certain type. This gives you a lot more fluidness to it and flexibility, but it also, if you're not careful, could introduce some unexpected behavior. So you kind of want to make sure you are being cautious when you assign things names or data types. So with that, we can now move on to another topic that's kind of interesting, which is map and lambda functions. So what is it? So a function without a name is kind of what it comes down to. That's what lambda functions basically are. They're essentially anonymous functions that can look like what we see down here, and we'll go ahead and make this a bit more engaging as well by looking at a lambda notebook. So imagine you have essentially an array of integers, and you want to do something to each element in that. You could do a function like define a function that basically says pass in this lambda function, right? And we use the keyword lambda. And what it's basically saying here is that it accepts in something. In this case, we're using the classic variable name of X. And then it does some operation to it. And in this case, that's basically multiplying it by 2. And so whenever we apply, we call this function that all it is doing is basically doing this. And we could definitely do this with less steps. It's returning 2 times that, essentially that vector. The same sort of thing can be done in a simpler way of just doing it in line. So you basically use the map function to do it as well. These are kind of doing similar things in a different way. The key takeaway here is that we're doing this without doing iteration. We're not saying for I equals 1 to 10, or we're not even saying for each item in the list do this, right? We're applying a function to every element in this case, for every element in some list, we're applying the function, right? So that's the part that's kind of cool. It's potentially for some a different way of thinking, takes some transition, but once you master that, then things become more powerful for you. And there's some things that are very difficult to do if you don't do it this way. So it's worth kind of getting past the resistance you may encounter as you're dealing with something new to try something different, right? So it is very much an alternative to explicit functions, because you can basically you want to use it for the duration of the execution, and that's it, and then you don't care. So data frames and dictionaries, probably two of the most common constructs you'll use. I'm trying to think if there's anything more compelling. Data frames is probably what you're going to do most of the time. It's what I do. Maybe vectors and matrices with NumPy, depending upon what type of work you do. But definitely data frames if you're dealing with any kind of textual tabular data. And that's exactly what it is. It's about rows and columns. Think of Excel or a database, but yet like more powerful, right? And you bring it in with as in a library that you sometimes have to install, but generally speaking, it's in most environments. Then you import it, and it is very, very similar to R's data frame. And then dictionary, name value pair, we talked a little bit about them. Sometimes has the fancy name of associative array. That's just a way of looking up something given something, right? So you're associating elements in an array with an index. Those are also very commonly used and very powerful sort of constructs. Sometimes you'll use them in a caching sort of scenario so that you can pre-compute some value and you look it up ahead of time. Sometimes it's just you want to find the equivalent of a select based upon a single field, and then sometimes an associative array is the way to do that. You could do something similar, obviously, with data frames, but it's kind of about what's the need and what's the problem you're dealing with. So we'll start off with the not so pleasant way of doing it, right? So it's always to show you the hard way first, right? So Python has CSV functionality built in. You can load from a CSV file. This first bit, don't worry too much about. I use the same notebooks in both Windows Subsystem for Linux and inside of just a Jupyter running inside of the Windows environment itself. There's reasons I do that, but the point of all this is to figure out which one I'm in and then map to the right location so that the files can load. And you'll notice here I'm doing some things like path.replace and a few other things, but nothing to get too worried about. So point of all this is we import CSV, and CSV is a library, hence the import. And we basically say open up a file. That's what this is doing. So we're figuring out what it is we're going to open, where's it at, what's the name of it. Then we basically I'm setting a value here to nothing, right? So none. And then I'm opening a file. That's what this is with open basically is saying inside of whatever is the context after that colon, as long as you're in that context, whatever CSV file there, the thing that is as will exist. When you exit that area, it goes away. So it basically gets, for lack of a better word, disposed of, right? So the file will be closed and the variable will essentially no longer be available. So what this is doing is we're opening it up, we're reading it, and then for the thing that we get back, we're going through each one of those rows and printing them out. And that's literally all it's doing. So you can see we did open up the file, we read it, we printed out the first row, which happens to be a header. That's kind of interesting. And then underneath of that is each one of the vectors essentially for each row inside of that file. A key thing to understand though is that the reader still continues to exist, right? And that's what this is. The CSV reader is being done by passing it into, we're passing in essentially what is a file pointer to a reader, and then the reader continues to exist, and that's what we're iterating across, right? It still exists, but at the point you try to do something with it, you're going to get an error because the file is closed. And it closed in particular at the point that we exited that with clause, right? So it's important to understand what's called scoping. So this stuff is scoped within the context of this colon. And recall that Python uses tabs to include sort of like scoping ranges. So this print statement is within this range, and then all this is within the higher level range. So it's an important concept to understand because you're dealing with files are considered scarce resources. At the point that you are done with them, you should close them. A failure to do so can have bad things happen, so that's why it's that way. But it's important to understand that it's not available to you outside of that scope. That's the next iteration here is to basically take it and rather than trying to read it after the fact, make it a little more complicated, right? Okay, so we do something similar. We still figure out the name of the file to open. We open it up. We get back our file handle. We take that file handle, pass it into the reader again, into the CSV file reader. And we do some stuff saying, oh, there's a delimiter, there's some quote chars, and so on. We go through and read out each one of the rows and print stuff out so that you can actually see the kind of the delineation. And then also, as we're going through each one of the rows, we do something, and this is not very pretty, but we're looking for that first row is the header, right? And so I'm looking for, okay, does it have passenger ID in the first thing, right? Not a real good way to do it, but it is a way to do it, right? And if that's the case, then I take the header and save it as the parts of that row. So we'd use another cool function that you'll use a lot, which is split. And what that does is take a string, so this row sub 0 is actually a string, and take it and convert it using the commas as the delimiters into an array, take that array, and then we say that is the header. Then for every row after the header, because we found it, we set it to true, yes, we found the header, we're into this else for every other row that comes through. And this is where we're using a dictionary. So, right, we create a dictionary each time through. We say for every essentially part of the line, and we're splitting each one of them again by commas. For each one of those that's from 0 to 1 minus the length, because we're 0 based, basically populate a dictionary with the corresponding header. So in this case, the first one is passenger 1 or passenger ID, then survived because that's the second column. P class is the third, and so on. We set each one of those with the part of it so that we're basically populating that dictionary with the corresponding name value pair for each one of the records. And then we take that dictionary and append it to a list. So we have a list of dictionaries, and that we can then potentially do something with if we're so inclined. And so you can see the end result is it is a list of dictionaries, and that's how a dictionary is visualized and also can be created, is using the brackets, I guess it is, or braces, the squigglies, and giving in the name and the value separated by commas with a colon between each one. So that's how we do dictionaries and lists of dictionaries. Kind of painful, right? And that's the reason why pandas came to be. So that's the hard way. Now the fun way, right? And the easy way. And pandas, I don't get paid for endorsing it because it's free, but it is good stuff. So again, same sort of code before. This is just figuring out where's the location that contains the data for this file. This is basically checking to see if pandas is installed. So I'm doing a pip install pandas. This is one way to do it. There's lots of other ways to do it, as we talked about last week. But what this is doing is making sure that pandas, and in turn things that pandas relies on, such as NumPy, is installed. So once it's installed, we can then import it. Generally, it's not hard and fast rule that you do that, but you'll see a lot of code examples where pandas is imported as PD, right? And you do that to avoid name collisions. So we imported it, and then all we have to do is say pandas, or PD, which is the alias for pandas, .read CSV, read underscore CSV, and give it the file name to read. And doing so, it read it into a pandas data frame. And that's what Titanic is. So if I add another cell in here and say, well, what is Titanic? It's actually going to make it pretty, right? So if I do what is the type of Titanic, it'll say that it is a pandas.core.frame.data frame, right? So it is a pandas data frame. You can use display, or you can just type the name in Jupyter, and it's smart enough to know that you're wanting to display it, and it shows it to you in a nice pretty format. It knows that this is a header, probably because the default is to say that there's a header, and then you can see each one of the values of each one. This first column is your index. It's not, so 0, 1, 2, 3 is literally the record number up to 890, and it started on 0, so that's why it's 891, right? So 0 based. And there are 12 columns, and the index is the first one. You can change that. You can set something else. If you wanted passenger ID to be the index, you can set it to be the index with set underscore index and say passenger ID on the Titanic data frame. Sometimes you want to do that, especially when you're combining together data frames, and it makes it a little simpler to join off of what is essentially the index. But it doesn't have to be, but it is something you might do. And you can also see there's some things in here that are NA, or NaN, which is basically it's null. There's not a value present. And you can do things to coerce those into a certain value if you want to do something else, or you can remove rows that have essentially null values. you do it depending upon what the purpose is. Again, the whole point of pandas is to make it easy to get to your data. And you can see, does it pretty quickly, pretty easily. You can also do things like a describe. And what describe does is give you common sort of attempts at statistical measures, right? So your mean, the standard deviation, min, max, and count. Count is probably going to be pretty close to the same except for those where there's no value, and that's why you're looking at 714, because there's a lot of them apparently with age that don't have value. Also, it's only going to be doing this off of numeric values, because what's the mean of a string, right? It doesn't make any sense. Some of these are categorical values, so survived, it's going to be 0 or 1 or something, right? So it doesn't make much sense to have a mean of that, other than if you want to know the percentage of the ones that actually survived, because it does have some value. But min and max makes no sense, because it's going to be 0 or 1, right? The age is the value here that would make the most sense and probably fair. So this can actually give you a sense that the mean, the average age, was just shy of 30 years old. And the maximum age was 80. The youngest was a little less than 6 months, so 5 months old, maybe 4 or 5 months old. So that gives you some pretty quick kind of descriptive analysis, hence the name describe, of the data frame. Pretty cool. You can also do things like take a look at the first row, right? That's what head does, and not surprisingly, tail does the opposite, the last row. And also really easily you can do things like box plots off of a data frame and various other things. So the takeaway is pandas is cool stuff. That is the takeaway. And it also is something that you will use a lot inside of pandas. As you progress through your career and you move into big data environments such as Spark, you'll probably use either koalas, which is a work-alike for pandas, but for a distributed computing process, or you may use the actual Spark data frame itself, which is similar, but not quite as nice as pandas, frankly. It's useful, but it's a little less mature, perhaps, because pandas has been around quite a while, and as I indicated, borrowed heavily from a previous work. So that is pandas in a nutshell. Good stuff. If you aren't familiar with it, do take some time and become so, because you'll use it a lot. Talking about data types and data frames inside of R. So a similar sort of concept, although a few less data types I think in R than there are in Python. So you do have the basics of integer, characters, numeric, complex, and so on. And you also do have the composites, vectors, which essentially is array, a matrix, and a data frame. So we'll go ahead and shift back over and do R at this point. As soon as I get into the right folder. And if you have any questions, do feel free to interrupt me, pause, or I certainly can take any questions. So don't let my babbling stop you from asking questions. All right. Basic data types in R. Integer, you can say something is explicitly an integer by putting L at the end so that you can be an integer. You can also say as.integer and give it something, and it will tell you what it is. Out of curiosity, let's see what is print class 1. So it defaults to being a numeric, and that's why if you want it to be an explicit integer, you want to either use the capital L afterwards. That's kind of, again, that's an old thing. We've done that for years in various older technologies. Less commonly used today, but probably more prevalent than you might think. We just typically don't do it. Or you can use the as integer if you truly want it to be an integer. Sometimes numeric is fine. Characters, kind of the same sort of thing. It's what you would expect. And we can see that it is it's a string essentially. So a character is a string. Numeric, again, a floating point basically. complex, imaginary sort of, the things that aren't real in the real world. And then logical, true, false. So not as many to talk about here, right? So a little simpler, perhaps. Then data frames, so moving into more complex and composite types. And hopefully this comes up for me. There we go. So we'll start off with vectors, and the it's interesting it's saying it's a logical. It's interesting. Let's see what happens if we do just this, and sometimes you have to just experiment. Yeah, nothing goes because there's nothing in it. So, okay, we're creating some other vector. We're basically giving it a series. And the type is the type of the vector. So it defaults to being a vector of integers, or I'm sorry, a vector of floating points, essentially. So we can basically say what is the type of it. And in this particular case, it's a double. And there are 3 things in it, right? So as we had set. Matrix, kind of a special case of a vector of multiple dimensions, and that comes in handy in later classes. I just finished talking earlier today about Markov models and Markov processes, and guess what? That's all about matrices, and it's pretty cool, pretty simple, especially if you understand how matrix manipulation works, but definitely cool. And then here's a data frame. Very similar sort of thing. You have a name, in this case of ID. You have some values. In this case, we're saying it's a range of 1 to 10, and then we're giving Y as a normal distribution centered on, it looks like 0. So pretty simple stuff, right? And you can also we'll go ahead and work through Titanic now. So talking about make sure I get the right notebook. Yeah. And looks very familiar, right? So same sort of thing. I'm just figuring out what folder things are in. And then this time it's there's no pd.read_csv. It's read.csv, right? In the name of the file combined with the path. And that's what this is probably the better way to do it. You'll see paste being used as well to just stick them together. This is actually smart enough to know if it needs to put the slash in or not between path, which is this up here, and the name of the file, right? So, and what I'm doing here is nesting functions inside of each other. So I've got read CSV, which is reading the CSV, and what it expects is a file name with a string inside of here, and that's what this is returning. So we can read it, and then we can take a look at it, and it looks a lot like pandas, right? So that's getting it read into a data frame. So once you get it read into the data frame, you're going to want to do some stuff with it, right? So that's where extending that to the next level, do a little bit of analysis on it, right? So don't assume that what you're seeing is all you have to do for your assignment. I'll put that disclosure or disclaimer in there as well. Do follow the rubric and do what it says. This is to give you some thoughts and perhaps give you a head start. So basically here I'm reading Titanic into a data frame, taking a look at it, which is what we just did. Now I'm taking a look at the first few records. I think it's the first 10 with the head. And no, it looks like first 6, and then it's the first, the last 6 with the tail, and you can see that the guess what? There's an index over here as well, right? And there's also a passenger ID which corresponds to the index. Then if you want to count the number of rows, you use in row and give it the data frame. In columns, and then if you want to know the column names, you can say call names, right? So pretty useful stuff. If you want to do some slicing, the first 3 columns, similar to what we saw in Python with dealing with lists, and it also works on things like data frames as well. So the same sort of thing if you want the 4th through 12th column. That's another way of doing it, right? So you use start at this location, go to this location. And then if we want to say, what does those look like? The head of R2. So I'm basically taking one data frame and I'm converting it into another by subsetting the columns I care about. And that's also a common pattern you'll do because you typically don't care about all of them. So what if you want to know just the minors, right? So those that are not 18 years old, use this command, and basically what you're saying is Titanic is the data frame we're interested in. You use the which keyword, so you're subsetting it on which right here with the brackets. Inside of that you say Titanic $age, so the age column of Titanic is less than 18. Comma and then bracket and return, and that's pretty cool stuff, right? And then you may want to either just in this case we actually are assigning it, right, and then displaying it. And once you've done that, let's take a look at, well, here's the box plot of age for Titanic, and you can see up here there's the 80-year-old, most of them are in here, and there's 40 to 20, a few down here with the youngest being there. If we take a look at just the set we just created, where I'm setting it to it, and then I box plot minor $age, you can see we actually are under 18, and you see a lot more narrowed in. So that's kind of the point of being able to subset your values. And sometimes you'll want to populate a data frame with an expression. So that's what with is doing here. So what we're saying is on the Titanic data frame, we want to create a new column, and we want to call it is minor. And we're going to assign it the value of true with those individuals who are less than 18. And so that's exactly what this line is doing. And you can see out here is minor. The age of this person is 22, and we're rightly saying they are not a minor. Let's see if we happen to catch a tail. Otherwise, we'd have to do some filtering to catch it. Close. We get a not applicable because there's no age for this person. So at that point, we've loaded up Titanic, and we did a little bit of simplistic analysis. So talking about Titanic, let's talk a little bit about deliverable 2. Your scenario is you're working as an analytics consultant, and you want to start producing some analytics to kind of demonstrate your skills, right? So that's the typical thing. So there's 2 submissions here. Your first one is you take the Titanic data set, and using Python, as an example, create an example of the application of the Python data dictionary data type, which is an associative array. We talked about those. In your example, you're to take one of the attributes of the data set and assign it as a key to another attribute, where one could create an associative array of males and females as keys. So you'd have a key that is male or female, pointing to a list containing the names of the people that are in that category. So I in the dictionary, I have male and female 2 keys, and if I do male, I get back a list of those that are male. Could even be 3 because there could be an NA in there, so are unknown. And you get back the list of those that have that characteristic, right? So the code I showed probably gets you pretty close to that, right? If you actually do it the way with looping it through the CSV, checking to see if you're in the header and past it, all that good stuff, right? So that could probably get you probably about 90% of the way there on that one. Note that each example should include the activity of reading the data set, parsing out the columns of interest, initializing the dictionary, assigning the attributes, and the appropriate key value relationships. Note that other key value relationships may require aggregation of keys by creating categories such as age groups, right? So you may have somebody that were young, minors, middle-aged, elderly, whatever. Okay, on your second assignment, you take the Titanic data set and use R to create 2 short programs that will demonstrate the use of data frames, right? Submit the source code. For both of these, I need source code in plain text. All that means is give me the .py or the IPYNB or whatever it is for the Python notebook, or the .r, right? So I need both of the source code as well. And then the next step is to read the Titanic data set, load a specific attribute column into an R vector, which you will then print to the screen, print the specific values out on the screen. And then this second, you reference two separate frames in a conditional output of the result on the screen, leveraging frames to print out, for example, all of the women on the Titanic that were under 40 or over 40, or two different attributes. So males in first class, or males over 20, or whatever. Make sure that you document your results with screenshots. So that means there's actually kind of three things you're going to submit: two source code files, at least two, maybe three, depending upon how you want to package up the two short programs, and a Word document containing screenshots, but it is important to deliver the source code. So here's the rubric. Target the mastery column, right? So this is how I will grade you, so do make sure that you look at this. You want to follow this explicitly because it is the secret decoder ring, if you will, to your grade. So I'm not going to read it to you. It's in the course room as well as in the syllabus. So if there's any questions about that, let me know. And since I've babbled on so long, we'll talk about the various IDEs and tools next time. So any questions? Okay. Thank you for joining, Corey. Appreciate it. And for those of you watching, let me know if you have any questions. That's what I'm here for. I want you guys to be successful. I do strongly advise, don't delay. I've seen a pattern in previous sessions where some students wait to the end, and it's unfortunate because you can't do all this in a short period. So make sure that you focus on staying ahead. I would recommend a module a week and a deliverable a week. That way you won't be scrambling. But definitely be proactive. If there's something I can do to help, let me know. Otherwise, stay safe, and we'll talk again next week.
Thank you.
You're welcome.